Welcome, and today in our second series of reactions we can't do in the lecture halls, we're actually going to be mixing iodine and aluminum, and take a look what happens. It's pretty cool.
So we're going to be mixing three things together. We're going to be mixing iodine and aluminum powder, and these will actually start reacting as soon as you mix them. It will take a few minutes for the energy of activation to be reached. So we're going to go ahead and hurry it up and put it on a bed of sand. This will contain the heat that's going to be generated later. We're then going to add a little bit of water. Now the iodine actually acts as an oxidizer, but it speeds up the reaction to add water. You're going to have aluminum iodine produced as a solid, and you will be releasing iodine vapor as a gas. So there's the first part of the reaction. As you can see, the aluminum iodine is being generated there. However, this is an extremely exothermic reaction. So after just a few minutes, the cool thing happens right there. It bursts into flames, and it'll continue burning until all of the aluminum is consumed by the iodine, producing the aluminum iodine. And it kind of sparks and fizzes, and it's a whole lot of fun. Again, this is one of my favorite reactions to do. This is something we can't do in a lecture hall because of the iodine gas that's produced. Iodine is toxic in gaseous form. It's not as bad as chlorine gas, but we don't want to put it anywhere near students. Now you may be wondering why in the equation I didn't show any gaseous iodine being produced. It's actually a byproduct because the aluminum is actually burning, so it's not a complete reaction. So the iodine that's lost as a gaseous form is correlated to the amount of aluminum that's burning, which you can actually do some pretty neat stoichiometry equations with that. Now there is one other cool thing you can do with this when it stops burning, because this is actually dependent on surface area, and when you put it in a lump like I did, there's not a lot of surface area. So when you break it up, you're creating more surface area, and you can get the reaction going again like that. Now there is another thing that I can show you here. This is one of those times where you don't want to try putting it out with water, because that just makes the reaction go again. Anyway, I hope you guys enjoyed this video, and I'll see you next time.